This problem is about limits and limits involving infinity based on a piecewise function. And for the record, if you fast forward about halfway through this video, you'll see the other version of this question, if that's the one that you need to analyze and look at. So for a problem like this, let's start with the first question, which is a limit involving infinity. If you notice, the first question they ask you is to figure out the limit as x approaches positive or negative infinity of this function. Based on this, we will use an end behavior model, which means we can take the limit as x approaches positive or negative infinity of really the greatest degree terms in the numerator and the denominator. In this case, the x squareds would cancel, leaving us with just 2, meaning the answer to this limit is simply a 2. When you find a limit involving infinity, if you get an answer like 2, you're actually finding the horizontal asymptote. So let's take the time now to write our equation of our horizontal asymptote, y equals 2. Next, when we try to find the limit at x as x approaches 0, you'll notice that by using substitution, we get 0 plus 0 divided by 0 minus 0. Since, of course, this leads to a 0 over 0, that means we need another technique, so let's try using factoring. If we take the limit as x approaches 0, and we take the factored version of this, let's factor out a 2x out of the numerator, giving us an x plus 5. And then let's factor out an x out of the denominator, giving us x minus 2. What cancels here? Well, the x's cancel out, which was why we got 0 divided by 0 in the first place. Now, if we try using substitution to figure out our answer, let's plug in 0 wherever we have x's left, and now we'll have 2 times 0 plus 5 divided by 0 minus 2. Calculating this answer will give us a 10 over negative 2, or in other words, a negative 5. The answer to this question is not 4. 4 is the point defined at x equals 0, but a limit is concerned with the height that we're trying to reach. So really we needed to use the actual function 2x squared plus 10x divided by the quantity x squared minus 2x. After factoring, we see the function is trying to reach a height of negative 5. More on this later. If we wanted to figure out the vertical asymptotes of this function, we needed to know what x values would give us a non-zero value divided by 0. In this case, if we look back at the original function, the denominator here is x squared minus 2x. Notice we factored that here in that earlier problem. So when would this denominator potentially equal 0? Well, one would be at x equals 0, the other would be at x equals 2. But keep in mind, when we plugged in 0, we figured out the limit equaled negative 5. That's evidence of what's called a removable discontinuity, or a hole in the graph. The only case for finding vertical asymptotes is actually setting x minus 2 equal to 0 and solving for x, which gives us x equals 2. So, our answers to this question are 2, negative 5, x equals 2, and y equals 2. Now, for good measure, to understand this question fully, consider looking at the graph. Here we have a graph of f of x that's been defined to be piecewise, where we use this purple function for f of x for all values when x does not equal 0, and this green point 0, 4 for when it does equal 0. Notice the point on our graph is 0, 4, but that's hardly the issue when we were trying to calculate our limit. When we want to find the limit as x approaches 0, we actually ended up getting an answer of negative 5. Take a closer look at our graph now to see this for yourself. And as we approach from the left, it seems like our function is trying to reach a height of negative 5. Notice the closer I get to 0, the closer those y values get to negative 5. However, it doesn't quite get there. We have a hole in the graph because our function is not defined at x equals 0. Instead, to be at negative 5, our function has been defined to be at 0, 4, here at this point. Notice that point doesn't affect our limit. Instead, we need to analyze where our function is trying to reach, which was clearly a height of negative 5. We found this limit by using factoring, but in this graphical representation, we can see that our function is clearly trying to reach this height as well. If you zoom out, you can see the asymptotes a little bit better. And if you notice, our function is flattening out as you go out to positive infinity or to negative infinity, which we calculated when we found our limit as x approached positive or negative infinity. We got an answer of 2. Notice now we have a horizontal asymptote at y equals 2. In addition, we have a vertical asymptote. It seems like as we get closer to the x value of 2 from the right, we're reaching infinity. And as we get closer to the x value of 2 from the left, we're reaching negative infinity. That's why we have a vertical asymptote at x equals 2. Now this is the same problem, but with a different function, in which we're asked to consider a piecewise function and calculate limits and limits involving infinity. So to begin, please notice that we are asked to find the limit as x approaches positive or negative infinity, which means we can once again use an end behavior model. This means instead of calculating the limit of our function defined piecewise, let's look for the greatest degree terms in our numerator and our denominator. Notice the x squares cancel out, giving us the limit as x approaches positive or negative infinity of the constant 4, which is 4. When you calculate a limit involving infinity, you're also finding any horizontal asymptotes if we do have an answer for our limit. So in this case, the equation of our horizontal asymptote would be y equals 4. Next, if we're asked to find the limit as x is approaching 0, notice if we were to calculate our limit using substitution, you do get 0 plus 0 divided by 0 minus 0, which doesn't give us an answer, instead an indeterminate form. This means we need another method to calculate this limit, so we'll use the limit as x approaches 0, and we'll factor our function that we have to be a 4x times the quantity x plus 2 divided by x times the quantity x minus 2. Now notice the x's can cancel, which means now if we try using substitution by plugging in 0, we will end up getting an answer of 0 plus 2 divided by 0 minus 2. And sorry, the numerator is being multiplied by 4. So in this case, you'll get 8 divided by negative 2, or in other words, a negative 4. A common mistake made in this question is for students to believe that the answer should be 5, but that's the point on the graph, whereas a limit is finding the height that a function intends to reach. In this case, our function is trying to reach a height of negative 4 as x approaches 0, as shown by this factoring method problem. We'll look at the graph in a moment, but now let's talk about vertical asymptotes. When trying to find the vertical asymptotes of a function, we need to set the denominator equal to 0. Well, once again, notice, when we factored this problem, we got x times the quantity x minus 2, which leads some people to believe that x equals 0 and x equals 2 are vertical asymptotes. However, when you try to find vertical asymptotes, notice that we had our x values canceling, which means that x equals 0 is not a vertical asymptote. It would not lead to a non-zero divided by 0. On the other hand, x minus 2 can be set equal to 0, which gives us a vertical asymptote of x equals 2. So to summarize, our limits are 4 as x approaches positive and negative infinity, negative 4 as x approaches 0. We have a vertical asymptote of x equals 2 and a horizontal asymptote of y equals 4. Once again, when you look at a graph, you can get a much clearer picture of what's really happening in this function. So here's the graph of our function, once again defined piecewise in purple to be the function 4x squared plus 8x divided by the quantity x squared minus 2x, except for when x is equal to 0. Instead, here in green, we have the point plotted 0, 5. Now, while we might see the point at 0, 5, that's not the limit as x is approaching 0. We don't look for the point on the graph, we look for the height we're intending to reach. So let's zoom in and take a look at where our purple function, the height we're trying to reach as x approaches 0. Notice you can see graphically it seems like it's getting to a height of negative 4, but as we follow in from the left, you'll notice that the closer x gets to 0, the closer the y value is getting to negative 4. But at negative 4, we have a hole in the graph, which I'm trying to get to here. A hole in the graph. Our function isn't defined to be at 0, negative 4. It's defined to be at 0, 5. But all evidence is indicating that as we approach 0 from the left or right, that our y value is trying to get to a height of negative 4. That's why our limit as x approaches 0 was negative 4. If you want to see the asymptotes and limits involving infinity, let's zoom out on this graph and take a look and see how this graph seems to be flattening out and trying to reach a height of 4 as we go all the way to the right, or a height of 4 as we go all the way out to the left. This tells us that the limit involving as x approaches positive or negative infinity is 4, and a horizontal asymptote exists at y equals 4. Finally, for our vertical asymptote, notice as we approach the x value of 2 from the right, it seems like our graph is going higher to positive infinity. And if we approach x equals 2 from the left, it seems like our graph is trying to get to negative infinity. This is indicative of a vertical asymptote at x equals 2. And for more practice with piecewise functions and limits involving infinity, try out these two questions. Notice that number 1, the limits are asking for positive or negative infinity and as x approaches 0, whereas for number 2, the limits are asking for x approaching positive or negative infinity and 3. Also, find the horizontal asymptotes and the vertical asymptotes of each of these functions. Good luck.